Hello everyone, my name's Tommy. I chose to do Taylor polynomials for this video. I'm actually going to be doing a problem that you've hopefully all seen from the Taylor polynomials homework that we did. So the reason I chose this topic was, which I also stated in a discussion post, that I really like the fact that it has a set structure to it. So when you're working through the problems, there's step-by-step procedures that you can go through, and as long as you do those steps correctly, your answer in the end will be correct. And I tend to like that kind of structured way of going about a problem rather than having tons of different ways of, I mean, there still might be multiple different ways, I'm sure, to do this, but having actual set steps to use for me is actually very helpful. So to start off, I'm just going to show the equations that you should know how to set up for the first and second degree Taylor polynomials. This is for the first degree, so you have your L of xy, which is equal to f of xy plus your partial derivative of x for xy times x minus x1, which you guys know these values are coming from this is your partial derivative of x for the given equation, and this x1 comes from the point that is given to you, and then plus fy xy and y minus y1. And this is for the first degree. So we will do the second degree, which is q of xy, which is then equal to your L of xy, which you will have found already, plus the partial derivative f of xx of xy, and that's divided by 2 and multiplied by x minus your x1 squared. Then plus f of x of xy times both x minus x1 and y minus y1. And it looks like I'm going to run out of room, so I'm just going to put this down here. And that's plus f of yy of xy also over 2, as you can see, kind of like what we did here. And that is also multiplied by y minus y1 squared. Alright, so the problem that I'm going to do today, which is your first problem on the homework that we did for Taylor polynomials, you have the function f of xy, which is equal to cosine of x cosine of 3y. And that is for x of y, which is near the point 0, 0. So you guys have all seen this already. So what I like to do when I go through these equations is to start off with my partial derivatives. So over here I'll list f of x of xy, f of y of xy, f of xx of xy, f of yy xy, and of course f of xy. Alright, so if we do the partial derivative of this function for x, we're going to get negative cosine of 3y times the sine of x. For fy, we get a negative 3 cosine of x sine of 3y. For fxx, we get negative cosine of 3y cosine of x. And then for fyy, we get a negative 9 cosine of x cosine of 3y. And lastly, f of xy, we get 3 sine of x times sine of 3y. Alright, so after I've done this, then I like to actually go through and plug in that point that you're given to find the values that you'll be using when you put your equation together. So I start off with just the function at 0, 0, and then I will list all the partial derivatives that I just found, except this time we'll be using the point 0, 0 to figure out what they equal at that point. So the value for the function, if you plug in 0 for both the cosine x, cosine 3y, you will get 1. For the partial derivative of x, you will get 0. For fy, you'll get 0. For fxx, you get negative 1. For yy, you will get negative 9. And then for xy, you will get 0. Alright, so now that you've gotten through all this, I seem to think that this makes everything a lot easier, because now you're basically just at a plugging in stage and solving for the equations that you find that you should know up here above. So we're going to start off by finding the first degree. So if we do first degree polynomial is going to be L of xy is equal to your f of xy. So we're going to use the point as well and plug this in all at once. So we will have f of 0, 0 plus your partial derivative for x, which is fx of 0, 0, and then x minus x1, which your x1 is 0, and then plus fy of 0, 0, and your y minus your y1, which is also 0. So looking up at the values that we have up here, we can easily say that f of 0, 0 is 1, plus f of x 0, 0, which is 0, and then your x minus 1, or minus 0, sorry, is just going to be x. So just for the sake of showing what this equals, we have a 0, we have an x, and this is going to be plus your partial derivative for y at that point, which is also a 0, and this also becomes a y. So if you look through this, this is going to cancel out because it's 0. This cancels out at 0. So you end up with this equaling, so we'll put this right here, L of xy is equal to 1. All right, so now we will move on to the second degree. So this one, as we said, is going to be q of xy, which is equal to L of our xy plus f xx of 0, 0 over 2, and this is multiplied by x minus your x1, which is 0, squared, plus f of xy of 0, 0 times your x minus x1, which is 0, and then also times y minus y1, which is 0. And I'm going to move down here again, plus your fyy of 0, 0 over 2 times your y minus your y1, which is 0, squared. Alright, now if we go and we plug everything in, so let's see, we have your L of xy, which is your equation that you found earlier, your first degree, which is just 1. So we'll put 1 plus your fxx at 0, 0 divided by 2, which if we look up here is negative 1 divided by 2, which is going to give us a negative 1/2. And then this is multiplied by your x minus 0 squared, which will give us an x squared here. So then plus your fxy at 0, which is 0. And then if you look here, you'll have x minus 0 and y minus 0, 0. And these will both end up being just your x and y, but since they are multiplied by 0 right here, that you get from here, which I'm just going to show that here, that'll end up canceling itself out. And then plus your fyy at 0, 0 over 2. Fyy is negative 9, so over 2 you're going to get a negative 9/2. And then same thing as before with the y minus 0, which is your y1 squared, you'll end up with a y squared. So just to simplify this a little bit, you are going to get q xy is equal to 1 right here, and then minus an x squared over 2. This goes away, and then you get to transfer this negative, which becomes a negative 9y squared over 2. So here is my answer for my second degree Taylor polynomial. Here's what I got for my first degree Taylor polynomial, and as you can see, I used this answer and incorporated it into this equation down here to find the second degree. And yeah, I believe that's all there is to it. Like I said before, I really enjoy doing these just because it's more of a structure, so it's not something where you're given an equation and told to find something and you can go about it a bunch of different ways and you can run into a bunch of problems. This way it's basically, if you know your steps, you remember how to set these up, your first and second degree Taylor polynomials, take the equation, you find your partial derivatives that are required, you find what their values are at whatever point you're given, and from there you just plug everything in, find the values, cancel things out if need be, simplify, and you'll end up with your answers. So thanks for watching. Any comments, concerns, or anything, if you notice I did something wrong or anything that you think would be better or more efficient for me to change, please let me know. But besides that, thanks. I look forward to watching you guys' videos, and have a good day.